We've introduced the growth rate of an exponential function, but now we want to look at how we can identify the initial value of an exponential function. If we have an exponential function, f of x is equal to a times b to the cx, where that value c would be the growth rate, then we can evaluate f of 0, which would be a times b to the c times 0. C times 0 would just be 0, so we'd end up with a times b to the 0 power. Anything to the 0 power is just 1, so we would end up with just a. For that reason, we refer to a, that coefficient in front of the exponential portion of our function, as the initial value. Oops. And thus we can identify the initial value and the growth rate of an exponential function just by looking at the function itself. We'll take a look at this in example 3, where we're given two functions. In part A, we want to identify the function with the faster growth rate. Growth rate means we want to look at the coefficient in the exponent. In this case, f of x has a growth rate of 6, g of x has a growth rate of x. So we can say that g of x has the faster growth rate, because 8 is larger than 6. Then in part B, we're asked to identify the function with the larger initial value. That's the coefficient in front of the exponential expression. So for f of x, that's 10, and for g of x, it's 7, meaning f of x has the larger initial value. Because 10 is greater than 7. And what this would mean in a practical setting is that exponential functions are often used to model things like population growth. If we were talking about our function g of x having the let's flip that around. If we talk about f of x having the larger initial value, that means the population modeled by f of x would have the larger initial population, but the population modeled by the function g of x would have a faster growth rate. So given time, that second population, g of x, would quickly overtake the originally larger population, f of x. So we're comparing which function has the larger initial value and which function will grow at a faster rate over time.